Today our topic will be on center of mass. You come across this term, center of mass. Whether it is center, the TRE, I mean the TR, the part of the it is the so, as I have said, we have different types. We've come across the gravitation and various types of conservation laws. So we'll be dealing with various types of conservation laws and gravitation and how does it affect and how does it relate with the center of mass. Center of mass question. So our theory related that we know and they are my also center of mass can allow what do you mean? What do you understand of what do you really mean by center of mass? That it is written here. It is the farthest point at which the entire mass of the body is supposed to be concentrated. 我们在做每周中专mass theory 嗰種都咁辦法。哦，咁別看，一啲人 scale 啲 input 打翻打到㗎。哦。So align there and more align that at certain center and the one in the kind of input to a center of mass in the there was a car scale and taken the watching to circular to irregular shape on a kind center of mass car align a pair of local center and the point or the place where the whole mass of the body or the object is concentrated is known as the center of mass. Okay, like if all the external forces acting on the body were to be applied at the center of mass, the state of rest and motion. In terms of external force, the center of mass can apply by external force to call negative force. Suppose if we apply all the external forces on the center of mass, then the condition of or the state of rest or motion of the body, it will remain unaffected. And that's rest are more motion at the moment. Center of mass. So, if you can see this diagram as shown here, so it is circular in shape. So we have three-dimensional, that is x, y, and z. Dimension. Okay, so we can write it and say that this figure is for two-dimensional. And as I have said, here I have diagram a picture and a table. We have the 3D control. One is along this one, forefinger, the thumb, and the middle finger. All right. So here it should actually appear like this, but in the on a page of paper, it we cannot draw it as it appears in the in the actual picture. Okay, actual okay. That now it will the point will be somewhere around here. Okay, so it will be like that. So if we are if we join the points here from here to here, there, and so on. So these are the position vector. So position vector, what is to come point like that. Okay? This is the actual point that we are considering. So this is the center of mass. Okay, so we are joining the center of mass with the origin of the coordinate system, and then that is the origin of the coordinate system is taken as well. And we join this at the center of mass, so we can take this as the center of the circle. Okay, and then we draw the circle around here, and then we draw a line from this origin of the coordinate system to the various point of the circle, and then we get various position vector. Position vector is to come with point at the center of coordinate system. Center of mass and center of coordinate system. Center of coordinate system. So like that too. Graph it with the center. Where all the points be. One. This is the center of mass. So we join a point, draw align with the center of mass of the pole. And then we get the position vector as capital R. And then we get to do another many more position vector as R1, R2, and Ri, Rx, and so on. Okay, we can draw it more if we want. So uh, what we are going to do is that we will try to derive the formula for, or we will try to find out the formula for finding the center of mass. Suppose we have a system of total mass. Okay, capital M total mass. And then one atong 10 kapit ibig ta 1 plus 2 plus 3 plus 4 up to 10 kapit ta kata at total ka kati ang m maka at total of all the masses, that is m1 m2 up to mn terms, right? So we shall have n number of particles whose masses are m1 m2 mi dot mn, then their position vectors are taken as R1, R2, R3, R4, and so on, Ri up to Rn terms. Okay, so I hope you know how to take the mean. Mean ka inlak lang kanina. Mean kan lang to estimate kan lang siya kanina. M1, the product of the masses and the position vector divided by the number of particles. Okay, the number of masses. So we will multiply M1 and R1. So we get M1 R1. Likewise, we will multiply M2 R2 and we will get M2 R2 2. So why do we put vector sizes above this whole R? Because they are vector quantity. Okay, they are vector quantity. Vector quantity means they are moving along a specified direction. Direction may be vector. That's one. Then we divide the whole terms by the sum of the masses. So it is taken as M1, M2, and Mi up to Mn terms. So if this one it is too long to see and to write, so we can rewrite this equation that I have pointed with an arrow there with the mouse. Then we can write the summation. This is the summation. Summation to the summation. So we can write M1 R1 up to Mn terms as Mi R5, where R goes from 1 to n terms. Oh, 1 to 3 up to n terms of value. So likewise, the denominator also can be written as in this form, like summation of Mi. So as I have said, the sum of all the m's are taken as capital M. Okay, here this capital M. So instead of summation of Mi, we can write capital M, and thereby we get this equation that is vector capital R is equal to summation of M by R capital R only center of mass so whole system. So here summation of Mi is equal to M. So this number would be minus. Okay, if you happen to say it from your book, you just correct it as equal to this would be minus. Okay, here summation of Mi is equal to M, which indicates it is the total mass of the system. All right, let's move on to the next topic, that is the center of mass of two particle system. So this one is only for one particle system, and the next we have the center of mass of two particle system. So we have two particle system as point A and B. Okay. Something like that. I hope you can see this one, the figure. So here we have the point A and point B, means it is of two particle system. Okay, earlier we are discussing only for one particle system, and then we join this point A from the origin of the coordinate system. and mark it as vector R1 and point B with, with the origin of the coordinate system, and then we get this line as the position vector 2 at distance between O and B. So this position vector is R2, and here here we have the center of mass. Okay, the distance in between our A and B, we have the center of mass. It may be exactly at the center. So whatever it is, then we call this with the center of mass between the 2 points. All right. So here we mark the center of mass as C, and join it with the center of the coordinate system, and put the position vector as vector capital R. Okay. So here we are writing something about the diagram. Some truth here today, the diagram control that we need to interpret what is and show the okay, figure control today. So, officially, the physics they have the empty part figure on the one. Support to have figure on the one. Mark attitudes to you. Oh, okay. So, in order to impress the examiner, as well as in order to clarify your derivation or whatever, you need to draw a diagram correctly. All right. So normally we draw this diagram in pencil. Don't do it in pen because it cannot be erased. One thing is that we normally draw it with pencil because it looks smooth and fine. All right. So OA the position vector of OA is R1 and the position vector of is R2. So here, C will be with the center of mass between point A and point B, and the position vector of OC as for the figure is vector R. Okay, so as we already know that velocity, velocity is the rate of change of position. Position vector and the answer rate of change of position. Rate of change of position with respect to time. Everything is measured with respect to time. Okay, here the frame of reference is time. So if I say that it is the rate of change of position vector, so it I mean that it is measured with respect to time. Okay, so since we are having two position vector R1 and R2, so the velocity for each particles will be V1 and V2. All right. So according to V1 and V2, we get this one position vector R1 and R2. So if we take the derivative, so the derivative of position vector R1 with respect to that is taken as the velocity V1. For R2, it will be V2. All right. So we apply external force. Means external force force. So we will apply external force on the particle of mass M1, which is at point A. So another external force is applied on the particle of mass M2. Whereas there will also be an internal force from inside to out from inside. Okay, which is called as internal force. So the internal force will be applied on M1 due to M2 from M2 to F1 F12 as well. Okay, so internal force M1. So capital F12. So internal force from mass M1 to M2 due to M2 divided 1 to 1. So if it is F21, so it will be internal force for the M2 due to 1. Okay. So I hope you have come across the term momentum or linear momentum. Linear momentum means momentum along a straight line. All right. So since in this diagram we are having this straight line, so it here it is also mentioned that we are having this linear momentum. So what is the formula for momentum? Momentum to P small letter P. So P is capital P, normally is pressure. Okay, so here small letter P implies the momentum, the linear momentum. Momentum is equal to mass into velocity. But since we are having two particle whose masses are m1 and m2 and velocity are v1 and v2 respectively. So we are writing the momentum of particle m1 as p1 vector p1 is equal to m1 v1. Okay, so we have come across the Newton's second law of motion in our earlier classes. It is F is equal to dp1 ma dp by dt, rate of change of momentum with respect to time. So this is the second law of Newton. Okay, so so we can see that the sum of small letter f1. What is f1? Like external force on the mass 1 and internal force on mass 1. And then so this is the sum which is the total force of the one mass 1 external force the internal force this one. Now we are now we are dealing with the particle of mass m1. So this is the rate of change of momentum, and then it is equal to the total mass of the total force acting on the particle. All right, so instead of p1 we will put m1 v1 vector here like this. All right, so similarly for the case of mass m2, their momentum will be m2 v2. Okay, p2 will be equal to m2 v2. Then shortcut to I have to tell me but I hope you will understand this thing. All right, so the sum of the external forces and the internal forces for the particle of mass m2 will be this one, and so we get equation 2.2 and 2.2 respectively. So we will add equation 2 and 3. Left hand side can be right hand side can be. So this is how it comes. Okay, so as we already know that f12 is equal to minus 2 opposite. Physics are minus 1 physical term 1 minus 1 but opposite direction. So if one is moving from left to the right, and if there is negative sign here, it implies that one is moving in opposite direction to that of the previous one, left to right. So that was that f12 is equal to f minus f21. So instead of f21, we are putting minus f12. Minus f12 is 1 plus f12 there, minus f12 0. So this is how f12 f21 f21 f12 small letter f1 plus f2. So the sum of f1 and f2, these are the external force and for mass m1 and f2 respectively. So the sum of f1 and f2 is taken as simply as f. All right, so this is the total external force. So we get this equation as we see. But we will differentiate. Differentiation. Okay, here we have differentiation, the first term of the left hand side of the equation. Also, we have d by dt here. The second term. All right, so we will take this d by dt outside because it is common for the terms. This one can differentiate the so a differentiator differentiation of u v formula u of m1 u of v1 so we get this differentiation like this. All right, so now what we will do is that d by dt will remain as it is outside the bracket, and whereas for both the terms we will take d by dt as a common terms, and then it will become m1 r1 vector plus m2 r2 vector, and the right hand side will remain as it is. So let us take this differentiation in this inside this bracket to the outside of the bracket, and then it becomes d squared by dt squared. So we will eliminate this third bracket, and then we get m1 r1 plus m2 r2 equal to f. Okay, so let us multiply the numerator and denominator of the left hand side by m1 plus m2. Why do we do this? Because we want to get the required result. Alright, but left hand side lamma panto or right hand side will be the left hand side of the equation of this one as a mouse up. But how chung le why m1 plus m2 the term of we will multiply the numerator of the left hand side by m1 plus m2, and then we get this one. Alright, so can be m1 plus m2 m1 plus m2 here cancel it. Be setting so we get equation 2.4. So as we already know, the whole mass is concentrated across or a mass center of mass, so a whole mass and concentrate na one position a whole mass C and concentrate that's in the position vector 2 vector r vector r. So equation of motion particle consider theta in shape level. No signal level to so I will be posting this one into here. I will show you afterwards. So m1 plus m2 that's what this square r by this whole term is the center of mass. So instead of all of this term, third bracket and the bracket here, so when we here vector r one, we will write equation 2.4 as equation 2.5 as this one. Alright, so we will compare equation 2.4 and 2.5, and then we can write as vector capital R is equal to m1 r1 plus m2 r2 by m1 plus m2. So we will solve again this equation, and then the numerator will come to the right left hand side of this equation, and it will become m1 m plus m2, close the bracket r vector r, and the right hand side will be as this. So we get equation 2.6. Alright, so from here we can conclude that the position vector is center of mass of two particle system is such that towards the center of mass of two particle system is 2. It is equal to the product of the total system. The product here the m1 r1 multiplier and so we will take the product of this one, and then if there are more terms, it will be m3 r3 plus m4 r4 only. But we are considering only two particles system in this equation. Alright, in this derivation. Equation 2.6 now because we are running out of time. So do so here case m1 and m2 in that's say m that's m1 and m2 but 1 or 2 on 3 m1 and m2 so instead of m1 and m2 we will respectively put m. So in this equation 2.6, so m1 and m2 m plus m. Likewise, instead of m1 and m2 we will put m1 m. Okay, so m plus m will be equal to 2m. So it m terms uncommon donor, so we will take m outside the bracket, and then we will get 2. So m 2m it can say so this one left hand side right hand side m can say this one 2 we will get 2r is equal to r1 plus r2, and then we will transfer r to the right hand side, and it will come at the denominator in the denominator. So we get the resultant of the can be resultant of the position vector as r1 plus r2 by 2. So this is means that the center of mass of two particles is equal. Masses lies exactly at the midway between them. Midway adalah terkait R1 dan R2 dengan ini 2 plus 2 divided by 2 itu 2 itu dengan 2 two particle system midway adalah terkait center of mass. So let's fascinate those that's all for today. So we will discuss the next topic in the next class. Alright. Okay, don't leave it now. Let me take the attendance and a screenshot. Okay. Now, if you want, you may leave because you're having another class. Okay, have a nice day.